welcome everyone. So what we're going to be doing right now is we're just going to be talking about how is it that you can solve problems where they ask you that a particular substance is going to be plated out. So sometimes they'll ask you for time, sometimes they'll say what's the metal that's being plated out, and if that's the case, then we know in order to find the molecular weight of a substance, we need what units? Well, grams over moles. And so what you do, everybody put your arm out. You go grams, moles, grams over moles. Okay? And so that could be the question. Or they could ask you what current is needed in order to plate out a certain metal for a certain amount of time. So there are different questions that can be asked. They're always the same. We're going back to our old problem-solving strategy, and so I do the steps as circle what you want, write what you got, throw in a bridge, and cross your units opposite. Now, the units are going to be different here, and this is going to be a really long problem that we're going to be doing, okay? So I want to make sure that you're first aware of that. We're going to solve this problem. We're going to start off on the left. You are going to use all of this space, so maybe try to write a little bit smaller than you're used to. I think it ends up being about 6 or 7 bridges, okay? And the units are going to be different from any of the units that we've ever used before, right? So let's start off and circle what you want. What are we being asked for in this question? It's right in the beginning. Minutes. How many minutes? So we're going to write minutes in the margin, and we are going to circle it, okay? So then it says, how long does it take to plate out? And they say 40 grams of nickel is what we want to plate out. And we're using a nickel sulfate solution. This is important. I'm going to come back to that as to why it's important. And the current that we're using is 3.450 amperes, okay? So my first thing is, we always say, when you're ending with one unit, you should be starting with one unit. It's not as obvious. This looks like one unit. It's not. That's not one unit, okay? If I write this out, do you remember Coulomb, so I can write it up here. So we said coulombs are equal to, do you remember the cool guy or the cool girl does what? Camps. So this is amp times second. We don't need the other part, but what would coulombs also be equal to? They find the joules over the valley. Very good. So it's also equal to joules over the valley. So joules over volts. Okay? Okay. So when we come back to this, if we take a look at this, this is in grams, which is 1 unit, and ampere is not really 1 unit. If I rearrange for amps, what do you get if we rearrange this? Coulombs over seconds. Awesome. So if I rearrange this, an ampere is actually equal to a coulomb per second. Okay? So that's not 1 unit. If I'm ending with 1 unit, I'm going to start with the 40.00 grams of nickel. Throw in a bridge, cross my units opposite, and where do we always go from grams? To moles. Okay, so we take a look at the molar mass, and nickel says 58.6934. So let's do 58.69. 58.69 grams per mole of nickel. Okay, here's where something weird happens, okay? So I'm in moles. What we're used to doing is doing a mole bridge here, okay? It kind of is, all right? It is a little bit of a mole bridge. I'm in moles of nickel, and the question though now is, we're talking about electrochem. And what's the important thing that's being transferred in electrochem? Moles of electrons. Awesome. So what we're going to do is, we're going to take a look to see how many moles of electrons. Well, you're looking at this and you're like, I didn't see a reaction. How am I supposed to do that? But what is the charge of nickel here? And how do you know? +2. How do you know that this is a +2 charge? Yes, because SO4 is a -2, so nickel must be a +2, because nickel can be a 2 or a 3. So that means that it's actually transferring for every 1 mole of this, how many moles of electrons are being transferred? 2. So I'm going to say 1 mole of nickel transfers 2 moles of electrons. Okay, how is that getting me any closer? Well, I've done this like mole bridge, semi-mole bridge, and now I'm going into moles of electrons. What do you know? There's a constant that contains moles of electrons. Faraday's constant. Awesome. What is Faraday's constant? It is equal to, it's 96,485 coulombs per mole of electrons. I'm going to show you real quick here how all of this is set up on the equation sheet before we use this, okay? So if we take a look at the equation sheet on here, scroll down right to the thermo and electrochem section, and down here I can see my delta G equations that are there, And here we've got I equals Q over T, okay? And over on this side, it tells you what I is. And I is current. And it tells you that the current is measured in amps. And Q, we know Q from Coulomb's law. Q1 and Q2 are just simply the charge, and they measure the charge in coulombs. So that's in coulombs, and T is your time, and that's in seconds. Well, there we go. Amps are coulombs over seconds, which is what we've already figured out by using our Camp's equation. Then if you come over here, you'll see Faraday's constant. There it is. So it's 96,485 coulombs per mole of electrons. And they also tell you that a volt is a joule over a coulomb. But the way that we memorized it was coulombs are the joules. You find the joules over the valley, which is the same equation. It's just rearranged. So they are given to you on the equation sheet. I just think it's easier if you have those memorized, if you've got a way of doing it. You don't have to worry so much about depending on the equation sheet in that case. Okay? All right, so let's come back to this problem here. And now we've got moles of electrons. So we said we can use Faraday's constant. So it's 96,485 coulombs per mole of electrons. So far, everything's canceling out. Now we're in coulombs. So we know that a coulomb is an ampere times a second, okay? Well, an ampere is a coulomb per second. So what we can do is, instead of saying 3.450 amperes, we can actually use the coulomb per second value. So instead of using this, we're just going to use this instead. So that's our coulomb right there. It's 3.450. And then per second, we're almost done because we don't want seconds, we want minutes. So I've got one more step, and we know that there are 60 seconds in 1 minute. And so all we're going to do now is let's multiply everything on top, and then don't forget, divide, 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 and let's figure out what this is equal to. Okay, so we get 635.4. I like that. That's 4 sig figs, and that's going to be in minutes. Everything else cancels out. That's 4, that's a count. That's 5, that's 4, and that's a count. So 4 is going to be our least number of sig figs. So that means that in order to plate out those 40 grams of nickel, you need to run this for 635 minutes at 3.450 amperes. Okay, so that's basically it for an electroplating. Again, the idea is you could be asked different questions. So let's come back up here for real quick for 1 second, because you could be asked to identify the metal. If you're asked to identify the metal, then what you would do is grams, moles, grams over moles. So that's grams per mole. What you would do is they would give you the grams, and then you would solve for moles using a bridge, and then you would just plug that right in, and that should give you the molar mass. Okay? All right, and that's it for working out the plating problems.